Today, I want to talk about a couple of review ideas before we start in on calculus. And one of them, and it's an important one, is the idea of a line. So we have 2 points, and the point is 1, 2, and let's say that the other point is 3, 6. The idea here is there's a line that goes through those 2 points. And what we would like to do is write down the equation of that line. Now, the first thing to do is to find the slope of the line. And the slope of the line is going to be change in y, which I'm going to call delta y, over change in x, which I'm going to call delta x. And now what we can see is delta y over delta x is, okay, so how much does y change? Well, we go from 2 to 6, so we're going to have 6 minus 2 on the top. And for x, we go from 1 to 3, so it's going to be 3 minus 1. So delta y over delta x is going to be 4 over 2, which is 2. Okay, so m is 2, the slope. Now what we would like to do is find the equation of the line. And the basic idea here is we're going to pick one of the points on the line. I'm going to choose 1, 2. We could do the same thing with 3, 6. We draw our line. Here's our point 1, 2. And now we pick an arbitrary point on here, which I'm going to call x, y. The idea is the slope of a line is the same no matter which 2 points you choose. So we're going to do our delta y over delta x stuff again. Delta y here is y minus 2, and delta x here is x minus 1. So delta y over delta x is y minus 2 over x minus 1, which is the slope, which we've already determined is 2. Now, if you take this expression right here, okay, that equality, and you multiply through by x minus 1, you get y minus 2 is 2x minus 1, and that is the equation of the line. And it's in what's called point slope form. More generally, if this point here is some point we know is on the line, which I'm going to call x naught, y naught, okay, and the slope here is m, the point slope form is y minus y naught equals m x minus x naught. And that's general point slope. So you find the slope using 2 points or some other way, and we will be using some other way a lot in this course. You find a point on there, x naught, y naught, and you can just write this down. Now you may be familiar with another form, y equals mx plus b, okay, where these 2 m's are the same, they're the slope of the line. This is the so-called y-intercept. So slope-intercept can sometimes be useful, but in this course, point slope will be more useful more often because we'll have a single point and a slope, and we'll just be able to write things down without doing any algebra. And oftentimes when we actually use this to calculate anything, this form is actually going to be easier to use than the y equals mx plus b form. Pretty clearly, however, these two are the same. So in the sense of they describe the same line, so we can convert. Let's take a look. Let's convert this into y equals mx plus b form. So we've got y minus 2 is 2 x minus 1. And what you do is y equals 2x minus 1 plus 2. You just add 2 to both sides. You multiply this thing out, 2x minus 2 plus 2, and that's y equals 2x, which is in fact the equation of the line. Now I'd like to say a little bit about functions. Now a function consists of three things. One of them is the set of inputs, and those inputs are called the domain. Then there's a set of outputs. The outputs are called the range. And then finally, there is a rule that takes an input and gives you an output. And we're going to draw those as arrows. And what I've drawn here is a representation of a function. Now, notice that these two inputs give you the same output. That's perfectly fine for a function. What you can't have, however, is a single input giving you two outputs. That's not allowed, okay? So for instance, f of x equals x squared is a perfectly good function in the sense of one x put in, x squared comes out, which is uniquely determined, plus or minus the square root of x is not a function. Because when I put in 1, what comes out? Plus 1 or minus 1. Not allowed. Okay, so this is not a function. This is a function. The standard rule here is if there's no domain specified, it's as large as it could possibly be. And here you can put any real number in for x. So x is allowed to be anything from plus infinity to minus infinity. So the domain in interval notation is minus infinity to infinity, meaning you can go as far that way as you want, you can go as far this way as you want. It's all legal. Okay, the range. Now the deal here is if you square a number, you're going to get something bigger than or equal to 0. So in fact, the range here is 0 infinity. And you'll note this square brackets here means that 0 is included. So anything bigger than or equal to 0 is allowed. If we look at the graph of this function, which I'm going to write as y equals x squared, you draw the graph, and what you can see is, okay, and this is, so for instance, this is the point here, 2, 4. The idea being that when x is 2, y is 2 squared or 4. You can see that there's another way to get 4. There's a minus 2, 4. That's perfectly fine. Now, if you look along the x-axis, you can see the domain. It's everything that hits the graph when you go up. And you can see that all x values are allowed. Now, on the other hand, the range is going to be what you can see on the y-axis. And clearly, this is not allowed. You don't have anything happen until y equals 0. And then you can get every possible y value from this graph. And except for 0, you get it twice. So let's look at the graph of a function. So I'm just sketching a graph. So let's make this the point -2, -2, 2. Let's make this the point 1, 1, and make this the point 4, 1. Okay, so that's the graph of a function. And what I'd like to do is figure out what's the domain and what's the range. Well, remember, the domain is the set of inputs, which are the x's that produce outputs. And pretty clearly, if you're on this side of -2, that's not going to happen. You start at -2, you're entitled to put stuff in all the way until x equals 4. So our domain is going to be closed -2, closed 4. Okay, what's the range? Well, again, we go up. We don't hit anything until 0. And then this piece over here shuts off at 1, but we've still got outputs over here until we get up to 2. So our range here is 0, 2. So you can read the domain and range of a function off from its graph. Last operation I want to talk about is functions of functions. So let's let f of x be, say, 3x plus 4. And we'll let g of x be x squared. Okay? And now the question is, what do we get when we write f of g of x? Okay, so the idea here is x is input into g outputs, and that serves as input to f. Okay, so what does f do? Okay, f takes an input, multiplies it by 3, and adds 4. So this is going to be 3 g of x plus 4, but we know what g of x is. G of x is x squared, so 3x squared plus 4 is f of g of x. Now, what's g of f of x? Here, g squares things, so what we're going to get is f of x squared, and now f of x is 3x plus 4. That's squared. And I could leave it like that, but just to make things clear, when you multiply this thing out, you're going to get 9x squared plus 24x plus 16. And the reason that I'm doing that is so that you'll recognize that f of g of x and g of f of x are different. It matters which of these you think of as the outside function, f here, g here, and which you think of as the inside function.